Hello everyone, good day. Today I will be explaining with you about determinant. But before I start, I am Marjeline Silobo, a second year BS Ed Mathematics student at Negros Oriental State University. So today I will be sharing with you on how to get the determinant of a 2 by 2 matrix, 3 by 3 matrix, and of course, the determinant of 4 by 4 matrix. But before that, what is determinant? So when we say determinant, it is a special number that we compute from a square of matrix. So when we say square of matrix, it is a matrix with the same numbers of rows and columns. So in other words, determinant is a number that shows whether a matrix has inverse and whether a system of equation has a unique solution. So determinant is written this way, that A or this one. It is basically read as determinant of A. So, let's have first the determinant of a 2 by 2 matrix. So, attached here is how the determinant of 2 by 2 matrix looks like. So, it has 2 rows and 2 columns. So, the formula of getting the determinant of a 2 by 2 matrix is this, that A is equal to AD minus BC. So in other words, you just need to multiply diagonally the A and D and BC. And after getting their product, you just need to subtract them. Okay? So let's have here an example of a 2 by 2 matrix. We have here the determinant A, whose entries are 3, 2, and 4, 5. Now, step 1 is we just need to multiply them diagonally. So, we have here 3 multiplied by 5, which is 15. And step 2 is to multiply the other diagonal part, which is 2 multiplied by 4. And it is 8. Now, after getting their product, we will just need to subtract them. So, we have 15 subtracted by 8 is equal to 7. So, determinant A is equal to 7. Now, so that is how we solve the determinant of a 2 by 2 matrix. So let's move on and proceed with the determinant of a 3 by 3 matrix. Anyway, in solving the determinant of 3 by 2 matrix, we have Sarou's rule and cofactor expansion. But we will just use the cofactor expansion since it is more applicable in higher matrices. So attached here is the formula of getting the 3 by 3 matrices. We have that A, EFHI minus B, DFGI plus C, TEGH. So always remember to apply the sign in this formula. So the sign is plus, minus, plus. So when we say the determinant of 3 by 3 matrix, it looks like this. We have 3 rows and 3 columns. Now, let's have the cofactor expansion, getting the determinant of a 3 by 3 matrices using the cofactor expansion. So, attached here is we have the determinant of a 3 by 3, the determinant of A, whose entries are 1, 3, 2, 2, 1, 1, and 3, 2, negative 1. So, for our first step is we just need to expand this along row 1, okay? So we have here 1, which is found in row 1, column 1, 1. And we need to eliminate the row 1, column 1. So by eliminating the row 1, column 1, the only item that we has is the 1, 1, and 2, negative 1. Okay? So we will just input this here. Next one is we have minus sign. And we have to get the 3, which is found in column 2, row 1. So, in eliminating the column 2, row 1, the only numbers we have is only the 2, 1, and 3, negative 1. And we will just input this inside these braces. And plus 2, and in eliminating the row 1, column 3, we only have 2, 1, 3, 2. So, just please don't forget the formula in getting the 3 by 3 matrices. So again, as we did a while ago with the 2 by 2 matrices, let's just do it again, okay? First one is we need to multiply it diagonally, the numbers inside the braces. So in multiplying this, we have 1 multiplied by negative 1 minus. Always remember to always subtract their product, okay? So 1 multiplied by negative 1 minus 1 multiplied by 2 is equal to 1 minus 1 multiplied by negative 1 is negative 1. And 1 multiplied by 2 is 2. And we just need to bring down the subtraction, and negative 1 minus 2 is equal to negative 3. So after getting the answer, we just need to multiply the negative 3 to the outside number of the braces. So 1, which is 1. So 1 multiplied by negative 3 is negative 3. So that is the answer. Let's just do the same thing with this following numbers, okay? The same process among this, okay? Now, after getting their product, we have here 15 and 2. And we will just need to solve them. So, negative 3 plus 15 plus 2. So, PEMDAS rule, we just need to add first before subtracting. So, 15 plus 2 is 17, and negative 3 plus 17 is 14. So, the determinant A is equal to 14. So, that is how we solve the determinant of a 3 by 3 matrices. Now, let's move on and proceed with the determinant of a 4 by 4 matrices. So, this is how the determinant of a 4 by 4 matrix looks like. We have 4 columns and 4 rows. Now, please don't forget with the sign pattern or the checkered board. We have plus minus plus minus, minus plus minus plus, and so on and so forth. So for example, we have here the determinant of A, whose entries are 1, 0, 4, negative 6, 2, 5, 0, 3, negative 1, 2, 3, 5, and 2, 1, negative 2, 3. The same thing as what we did earlier. We just need to eliminate the row 1 and column 1 and proceed with the same process as what we did a while ago. So, let's try to solve this one. So, we have here the 1, and by eliminating the row 1 and column 1, the only number that we left is this, the 5, 0, 3, 2, 3, 5, and 1, negative 2, 3. That's first one. And the second one, we have 0 in 0. So, we need to eliminate the numbers from row 1 and column 2. In eliminating this number, the number that we have left is the 203, negative 135, 2, negative 2, 3. That's a minus sign. Always remember. The third one is we need to have a plus sign. So we go through the row 1, column 3. So we have 4 here. Now, in eliminating the row 1, column 3, the only numbers that left is 253, negative 125, and 213. So that is the only number that we need to write inside these braces. And lastly, we have negative 6, and we need to use the minus sign since our sign pattern is plus minus plus minus. Okay? So, and eliminating the row 1, column 4, the only numbers that we have is 250, negative 123, and 21, negative 2. So, after having these items, we need to eliminate the items with this 0. Because basically, when you multiply 0 by any numbers, the answer is basically 0 itself. Okay, so we just need to eliminate that one. Now, in solving the determinant of this item, we just need to do it like this. From 3 by 3 matrices, we need to do it in a 2 by 2 matrices. So, we need to first solve the first one, which is 1, whose matrices are whose entries are 503, 235, and 1, negative 2, 3. So, the same thing as what we did earlier. We have here 5. We need to eliminate the row 1 and column 1. And the only number that we have is 3, 5, and negative 2, 3. minus 0, 2, 5, 1, 3, and plus 3, 2, 3, 1, negative 2. So, after cross-multiplying this item, after getting their product, we just need to subtract them. So, 3 multiplied by 3 is equal to 9, and negative 2 multiplied by 5 is equal to negative 10. So, 9 minus negative 10 is equal to 19. Now, after getting the answer, we just need to multiply 19 by the outside number, which is 5, and 5 multiplied by 19 is equal to 95. So, in this part, we just need to eliminate the 0, which because 0 multiplied by any number is equal to 0 itself. Next, let's proceed to other matrices, which is this. So, 2 multiplied by negative 2 is negative 4, and 3 multiplied by 1 is equal to 3. Now, negative 4 minus 3 is equal to negative 7. So, we just need to multiply negative 7 by the number outside, which is 3, and 3 multiplied by negative 7 is equal to negative 21. After this one, we just need to get their answer. So, 95 minus 21 is equal to 74. Now, since our answer is 74, we need to multiply 74 on the outside number of this matrix, which is 1. So, 74 multiplied by 1 is basically 74 itself. So, the same process goes to the following matrices. For this part, we have here the 4 whose entries are 2, 5, 3, negative 1, 2, 5, and 2, 1, 3. You just need to do the same process as what we did earlier. Now, our answer here is 52. But 52, let's multiply 52 to the outside number, which is 4. That's why we have here 208. And the same process goes with this item. In this part, we have here the answer is negative 36. Now, let's go back to the upper part. We just need to input the answers. So, we have here 74 minus 0 plus 208 minus negative 36. Minus because that is basically the operation that we need to use. So, we have here 74 minus 0 plus 208 plus 36 because minus both minus a negative sign, when we combine them, that results to positive sign. So we have here 74 minus 0 plus 208 plus 36. And the answer is 318. So our determinant A is equal to 318. So yeah, that is how we get the determinant of a 4 by 4 matrix. So again, it is really very easy. You just need to know how to solve the determinant of a 2 by 2 matrix and 3 by 3 matrix and a 4 by 4 matrix. That is basically so easy if you have mastered their formulas and apply the signs. Okay? So yeah, that's our topic for today. I hope that you will learn something and never stop learning mathematics. Because again, according to Mom Normina, mathematics is fun when one learn with enthusiasm. Okay, so that's all for this video. I hope that you appreciate this. Thank you and God bless.